Alrighty, waiting for us to be live. And let's see. Let's see if this actually works. Hello, there we go. Alrighty. So it appears that we're live. And now let's start with our stream today. Alright, so welcome to another stream. I'm a little on the go today, so we're sorry for the poor camera quality. We're also testing out my new lapel microphones here, or lapel. I don't know. Either way, so today what we're going to be doing is checking out something called the STM32 Discovery Kit, and it came in this box, and I have not yet opened it. And so we're going to be hopefully going through like the IDE setup for it and hopefully trying to get a couple of examples running on it, because I have not ever used an STM32. Well, actually, that's not quite true. I've really not used an STM32 before. I have, I had an STM32F4 Discovery Kit a long time ago. I still have it. I just never did anything with it. So I think I ran one sample on it and then kind of forgot about it. But either way, STM32U0 Discovery. And that's kind of what it looks like. And I'll pull up a link to this. So STM32U0 Discovery, or DK, U083CDK. There we go. All right. Yep, STM32 Discovery. So yeah, so this is essentially what we're looking at today. Looks like this. It's got a little bit of it's got some Arduino headers, some breakouts for other things. It has an integrated ST-Link debugger, and then it also has an additional USB-C port for the microcontroller's onboard USB controller, which is why I got the Discovery Kit specifically and not the Nucleo, because the Nucleo doesn't break out the USB controller that's in the microcontroller that this kit ships with. So the reason we're going to be checking this out, actually, I brought a couple of things to potentially work on today, but I think this might be the most realistically useful to people. So I got my baggie of goodies, right, that I brought, on my little, I'm on the go today, so we're testing mobile streaming setup, right? Got a couple of Arduinos in here, Raspberry Pi, Pico. So the thought was either we're going to do the STM32 board because I got this in the mail a couple days ago and wanted to check it out, or we'd do essentially a random Raspberry Pi Pico project would be implementing QuadSpy with DMA on a RP2040. Its integrated support is in hardware for the 2350, so we don't have to worry about that anymore. But if you're still on a 2040, it'd be cool. And I had made these, what do you call them, PMOD modules for an FPGA board that look like this. Essentially, it's 16 megabytes of pseudo-static SRAM. And then the other one would have been implementing a ChibiOS SIO driver for the Arduino, or the AVR microcontroller that's in the Arduino, because it doesn't have one, which means that if you actually want to do any low-level serial work, or your own protocol or something other than a text console, it's not particularly efficient, because the only thing you get is the serial API, and just really meant for using with the channels interface, which is meant for text mostly. But either way, figured that since kind of the goal of the stream is to keep things, hopefully do things that are relevant to people, right? I figured messing with an STM32 might be the most realistic thing to do. So let's quickly unbox this, and there's not a whole heck of a lot in here. There's just okay, fine, I lied, I did open it, but I just wanted to see that it worked. Okay, yeah, so here it is. Comes in an anti-static bag. I think there's just a little advertising, or little card in here for something. Oh yeah, just literally the link that we're looking at right now, there's a QR code on there. So take this out of the anti-static bag, and this is what you get in the box. It just comes with this board. There's that USB interface for the debugger on top. There on the bottom, there's the onboard USB from the microcontroller. It just breaks out some I/O. There's a little like joystick thing that's nice that we can do something with. There's a capacitive touch sensor, and I don't really think there's anything else. Oh yeah, there's this segment LCD. And as far as other input or output devices, I think that's it. There's a couple of LEDs. But that's pretty much it for things on the board. But realistically, what we're trying to do here, we wanted this to mess with the USB interface. Because the STM32U0 series specifically is designed for battery-operated devices. There is a very low, besides just in general drawing not much power, the chip has a collection of ultra-low power modes that can get the power consumption under 1 microamp in sleep, which is great for battery-operated devices. And then for USB, I believe, if I'm understanding the datasheet correctly, if you put the CPU into suspend mode, or not suspend mode, if you put it into low power sleep mode, you can, or maybe even stop mode, you can, the USB, if the upstream USB controller is only, if the upstream USB device is in suspend mode, then it actually, you can drop the power consumption of the chip down to something like 100 microamps, even with the USB peripheral enabled. So kind of the idea is that for battery operated devices, if nothing's plugged into the USB port, you don't even worry about USB. But if something is plugged in, you can still operate in low power modes, as long as the upstream device isn't requesting packets from you. And here we're just going to check the comments, see if anybody's here. Nope. All right. So let's see. All right. Yeah. So the first thing that we're going to do, because there's no sample project on this thing. If we plug it in, nothing much happens. Like if we plug in, gets power over the debugger, it, powers up, blinks at me. Yeah, that's just about it. The demo wasn't installed on this one for whatever reason. So we're going to try to get the demo installed, and that's going to require something called the STM32CubeIDE, which I have never used. And I don't even have an account on ST, so we're going to have to create one of those. So we're going to look at how to get STM32CubeIDE on Linux, because that's what we're running. Get software. Let's look at the Linux version, right? Download version 19, accept. Oh, okay, I gotta create an ST account. All right, let me turn off my screen capture here, just so y'all don't look at my password lengths, right? We're gonna turn off screen capture. Just go through here, define an account. Let me create a masked email because I don't like things having my email that. All right. Masked email, new email, copy. Don't want y'all having it either. ST Microelectronics. Save. I'm gonna do an email function. I am a hobbyist. All right, we're gonna call myself an engineer. In the industry of hobbies. What am I in? We're going to say, oh gosh, computers and peripherals, why not? I'm in the US. That's about all I'll say. I'm in California, but US, California. Won't give them my phone number because why would I do that? Alrighty. Function. I'm a software guy. Why not? All right. So we did that. I accept the terms of use. Register. Thank you. Confirmation has been sent. So we'll do that. Fast mail. See how long this takes, huh? There we go. Confirm your address, validate. And let me use... I still got this turned off, right? Yep. All right, good. Okay. Electronics, save. All right. Submit. Registration has been completed. Alrighty. Perfect. Now I can just refresh this page. Turn my screen cap back on. All right. Now we want STM32CubeIDE. All right. Now that we've logged in, we're going to get the software. We're going to get the latest version, accept the license, log in, whatever. Log in. All right. Get software. And it's downloading. Oh, good Lord. It's going to take... Well, that's going to be a while. Oh, no. 9 minutes, 10 minutes. Oh, so I'm going to have to talk for a while this downloads, I suppose. All right. That's uncool. Still falling. Gotta love hotel Wi-Fi, right? 1.1. It gave me 10 megabit. Oh, that's not nice. Okay, well, I guess I can't monopolize the hotel Wi-Fi. But, all right, so we're going to talk for 16 minutes while this downloads, right? Okay. So, what can we talk about? So, while we wait here, I guess I can give a bit of an update on the robot project. So last time we got micro ROS working, we got a laser scan coming out of it. We were using FreeRTOS, but I didn't quite do it correctly, apparently. I'm in the next stream, we'll talk about it, but you actually are supposed to enable a multi-threaded setting in micro ROS, or specifically in the micro XR CE DDS thing. Otherwise, it's not thread safe, and we're using threads, so the fact that it didn't explode is kind of a miracle. So we'll have to address that in the next stream and do that correctly. Also, I didn't do the what do you call them? The min and max range on the laser message correctly. The min and max range are not the smallest laser distance and the largest laser distance as we set them up as. It's actually the minimum and maximum valid ranges of your LiDAR. And also the value of the extent of the laser scan should have been 0 to 2 pi because it's a 360. It's not the value of the last one. It's essentially the value beyond the last one. It's a range not inclusive on the end. So we'll have to fix that in the next stream. And let's check, see if anybody's commented. Nope. Okay. So let's see here. We're still waiting on that download. It's going to take another 15 minutes. All right, so let's see if we can even... So don't necessarily know if I quite want to talk about what I intend to do with this right now. Or my ultimate goal of what to develop until I flush out all of the features, right? Let's see. Wait for this to download. That's the problem. I wish that if I was at home, this would have gone, super quick. Actually, while we're sitting here waiting for that to download, I might as well show you the CubeOS thing that I'm thinking about doing. So somehow, by posting patches to the forum, I have become the AVR maintainer of CubeOS, which is a little scary, I'm not going to lie. But if we look at Chibi, I'm going to have to sign in to be able to search, right? Continue with passkey. There we go. There we go. So OS, basically what we're going to have to wait on here is, again, for anybody who's watching this later, we're just waiting on this download to finish for CubeIDE. So I'm just going over kind of one of the other things that we're looking at, or that I'm looking at, not intending to do tonight. Or maybe we do it if this doesn't. Maybe if there's not too much interesting to do here, we'll do something else. But specifically, I added support recently for, there's a HAL ports AVR. There we go. So yeah, I added support in CubeOS Again, somehow I've become the AVR maintainer just by posting patches, because apparently I'm the only one who cares right now. And realistically, like, yes, the AVR is an old platform, and everybody should probably be using 32-bit ARM microcontrollers, or ESP32 or something else at this point, because let's be honest, they're 1,000 times faster. They have 100 times more resources, and they don't cost anymore. They might even cost less. It's cheaper to buy, like, our Pi Pico costs $4, and Arduino Uno, even the cheap knockoff ones, cost like $7. But anyway, because I have Arduinos in I have an Arduino in my robot. I wanted to kind of essentially, the kind of the logic was, I built this hardware in here and I never fully utilized it, so let me fully utilize it before I replace it, even though I already have in mind what I want the replacement to be. So, maybe it's a waste, maybe you consider that a waste of time. I just kind of wanted to see the logical extent of things, and I want to clean up all the horrible stuff we did in that CubeOS migration, because turns out that stream that we did a few months ago with the CubeOS migration on my Magellan robot, I actually took that thing out to run it, and while it ran around in my living room just fine, the moment it actually had load of all of the navigation sensors working again, it just fell over, or the microcontroller code that we wrote fell over. So I ended up just reverting it back to the pre-CubeOS version of things, and not using the IMU that we were doing that migration for in the first place. But that being said, I added support for pad event, or CubeOS has this concept called pad events, which is what it calls basically GPIO interrupts. Like, if a pin changes or a interrupt pin triggers, it uses you can enable events on a particular I/O pad, and you can add a callback or wait for an event to block a thread until the state changes or something. So I went in and fixed, or well, didn't really fix, I implemented pad support for for this platform, because I wanted to use the AVR and I needed pad events. So that's what I did. And so yeah, so that's either way. So that's in there. But the thing is that all we have for the UART is the kind of the old serial driver implementation, and this is a buffered interface, so we don't have control over the low-level buffer. So we have to do that thing where it's like, okay, read a byte at a time, read a byte, read a byte, read a byte, read a byte. And I would rather not wake the thread up until a frame was received, because remember we were doing it read byte, read byte, read byte, and if it hit that 0 number to be the sentinel for a new packet or the end of packet, we had to essentially kept having to wake the thread back up, read 1 byte, go back to sleep, waiting for the 0 to show up. Whereas if I had control over the low-level buffer or had control over the interrupt from the UART, I could basically say, inside the interrupt handler even, only wake up the upper thread, if you see a 0 come over. And otherwise just buffer it and don't do anything, and it'd be far more efficient. So in order to do that, for other platforms such as STM32 and CubeOS, like let's look at the U3 series, or no, not the U3, LLDs, low-level drivers. If we were to look at, if we go to their latest, so they have what's called an SIO driver, which removes the buffering. It's basically just a low-level hardware interface to the UARTs. Let me actually look at the implementation for STM32. So they have this low-level implementation. It just does the interaction with the hardware. It's up to whatever you set the callback as to handle buffering. If you want to use built-in buffering in CubeOS, like the existing serial driver already does, there's a high-level driver called a buffered SIO driver, which you give it an instance to an SIO driver, and it'll basically be what was before. Or you can just skip that buffered SIO driver and then write your own buffer handling as you want to, right? Did I? Okay, no, I did turn I did turn the freaking thing back. Oh, something broke. Oh dear. Is nobody actually seeing the live stream? Oh. Something's goofy. Hold on. Okay. Sorry. We're back. Also looks like my webcam might have frozen. Oh, nope, never mind. I can't, sorry, it's in the, that video's in the past, sorry. All right, so yeah, so we would want to do the SIO driver at some point for the AVR, and we still have 9 minutes left on our CubeIDE download. Alrighty, so let's see. Kind of what I want to get done today with the STM CubeIDE, maybe, or at least is I want to run whatever demo came with the board. I want to run that because I think that drives the LCD on here. That might be cool. But also I want to see if we can get go for broke and see if we can get USB-CDC working. Get basically a serial port over the US or a virtual serial device over the USB port. Maybe even if stretch goal of a composite HID device, because I think there's actually a sample for it implements a HID device and also the serial device over the same port. And that would be really cool because we could talk serial for our debugging, and then we could also talk HID device to make it do something like, let's say we build a mouse jiggler or something. I don't know. And another thing to look at while we're here is this thing called Embassy, because or not Embassy Suites, Embassy RS, right? STM32U083. Oh, interesting. I had taken a couple of looks at this before, but basically, when we're using ChibiOS or FreeRTOS or something on one of these microcontrollers, it implements a lot of it is a preemptively scheduled real-time operating system, but pretty much that it implies that the OS is preemptive as well. So there are threads. Each thread has a stack. There's no way around that, or not too many ways around that. Embassy. So again, Embassy. This is not a C++ thing. This is a Rust project. But rather than using a context switching kernel, rather than using threads, and context switching, what Embassy does is it actually uses the Rust async platform or async system to essentially give you the illusion of having you can write your code concurrently, and it can still execute. So you can have async tasks running, but technically, because the whole thing is glued together with async await and Rust, it actually runs on one thread. There are no threads. Like it doesn't have to do context switching, and there doesn't have to be multiple stacks, and that's one of the big advantages. Basically, it turns your whole program. You can write it as if it was multiple independent threads of execution, but actually, it really is only one, and it's glued together by the async system. Effectively turns the whole thing into an event loop almost. So this lets you do, write code like this, essentially where it's like, oh yeah, I'm gonna do a thing. This is my main. I have a loop where I'm doing something. I'm writing stuff out to the debugger, but yet I have this task running in the background that just blinks an LED, sets high timer, and you see this is an infinite loop. You see that this is an infinite loop, but you can almost imagine that anytime you call await here, it's giving up the thread of execution. It's not a thread, but it's essentially doing a coroutine yield, for if you know that terminology, to something else. So you could have two completely separate loops that look like infinite loops, but they actually are giving time to each other anytime you hit one of these await points. Essentially is a yield. So this lets you write some pretty nice looking code. Wow, yeah, lets you write some pretty clean looking what otherwise be multi-threaded code without actually having threads, which is super powerful. And there is support for the STM32 because it's pretty much one of the most popular ARM microcontrollers right now. And then there's also support for the RP2040. I don't know if they have the 2350 implemented yet. They probably do. Let's see, RP. Do they have the 2350 implemented? That'd be the Pico 2. Embassy HAL 2040 as well as 23. Okay, cool. So we get 2350 support in here. So this is the Pico 2. Wow, looks like it has a lot of issues. Well, that's funny. But either way, oops. So at some point, we're going to try to mess with this because it actually has a USB driver and has HID support and has CDC support. So that'd be cool to get this working at some point. I think what do we got here? Source. Yeah, builder, control, descriptor. Yeah. Anyway, all right, we're almost there. I gotta fill another 4 minutes. Okay. Let's see here. It's probably gonna be a short one. I mean, I'm on a business trip right now. I don't want to stay up too late. But anyway, yeah. So on one hand, we got that. This is kind of, I ultimately want to like run Rust on this thing, right? Because you know, I haven't done too much Rust microcontroller development, and that'd be really cool to do in the STM32 because it's well supported. Or the STM32 and the STM32 is probably the best supported embedded platform for the Rust embedded ecosystem. And I don't know how well supported the RP2040 and RP2350 are, but because of how hobbyist friendly those are and approachable, they probably are not too bad. But anyway, so yeah, we're still waiting on that. Oh, let's look at some examples for Embassy. What about, what examples do we have for STM32U0? That'd be cool. Source, bin. Ooh, we got some demos. Let's see, Blinky. What does that look like? Oh yeah, just in a loop, print high, low, blink a light. That's cool. USB serial. Look at that. Oh, look at that. There's already a whole big example on how to Oh, that's cool. Look at that. There's already implementation of, that's actually a really short program. That's 100 lines of code. We have a full USB-cdc stack. Like that's really neat. We'll have to, and that's on a U0. That's the board we got. That's cool. I like that. What cargo.toml? What does this do? What does this use? Out examples embassy STM32 ... Huh. Interesting. I wonder how long it's going to take to clone this. Anyway, well, we could once CubeIDE is downloaded, we're going to start installing CubeIDE. Then maybe I'll cue the download for this. That'd actually be really cool. But anyway, and yeah, so we got that with the Rust and. Also that, I kind of went over here, the idea of writing one of these SIO drivers for AVR, because I am now the AVR maintainer. But let's see. All right, we got 1 minute left. Welcome. All right, so yeah, if you're just joining, we're waiting on, we got another 58 seconds for CubeIDE to finish downloading. I've never used CubeIDE before. We're just we're taking a first look at this STM32U0 discovery board that I got, and kind of our goal for today is that we're looking at but by the end of the stream, I really want to have at least USB serial or USB-CDC, so virtual serial port. Really would like to have some sample, whether we write it or we just load a demo from ST Microelectronics and just end up like just thumbing through it just to see how it works. The other thing that would be cool is maybe we can while we're waiting on CubeIDE or after we do stuff with CubeIDE, run one of these STM32 embassy samples, which is a way to write, which is a kind of a Rust based, not kind of, it is a Rust based embedded environment for a bunch of different microcontrollers. But it's built on top of async, so you kind of get the paradigm of being able to write multiple tasks as if it were like an RTOS, that like FreeRTOS or Chibi. You can write it as if they were multiple threads, but it actually uses the async await system to what do you call it? to provide this illusion that you write concurrent code. So if you're sleeping for a while, you're calling await, which will yield execution to something else that could run. So basically cooperatively schedules all of these. Interesting. Which is cool. Anyway, all right. It downloaded finally. Okay. And we lost everyone who was looking. Okay. Okay, so it's downloaded. So we're going to go to downloads. And we're going to tarxvf STM32. Wow, that's a zip file. Wow, I'm terrible. Okay, unzip st. Oh, is this going to be one of those freaking just self-extracting shell scripts that I have to run as root in order to install it? Because that's disgusting. So we're just going to do sh st. All right, yeah. Creating a directory. Uncompressing the installer. We're going to have to agree to this giant... Ah, no! Okay. Just keep hitting the Y key or something until it works. More. Oh, if I go past the end, I accept. Do you want to install ST-Link server in UDEV rules? Yes. Install dir. We're going to put this in home and Lewis bin STM32CubeIDE /1.19.0. There we go. Let's see what happens. Extract it. Well, we're presuming that it's working right now anyway. And while that's doing its thing, let's clone this embassy thing, right? We'll give ourselves another terminal, go to sources, git clone embassy. That's probably going to have a lot of files to download, so we'll let that run for a while, you know. Let's see how our installation here is going. Password. I don't like that. Oh no. All right, I accept. Oh dear. I accept. Do you want to install J-Link rules? Sure. Oh, good lord. We don't want to go past the end because if we do, it's just going to fail. High-risk activities. Don't sue us for any dumb things that you do. Oh. Oh no. Oh no. How? Oh no. Oh no. Ugh. How many clauses were in here? I don't want to scroll past the end of it on accident. I really, really hate... Can I just hit Q? I can just hit Q. Okay, perfect. Okay, that's nice. Okay, so we installed this. So let's remove this shell script. Go to bin STM9. All right, and then we're going to do STM32CubeIDE. Look at that. It's loading. And we're going to go to CubeIDE workspace 1. Yeah, why not? Why not? We'll just let it do that. That's gross, but we'll just let it do that. I'm probably going to have to log in to... let's see. Well, that's brilliant. We'll just close that. All right, so we're in CubeIDE, and it opened a thing. All right, neat. Release info, added support for stuff. All right, that's fine. How's our embassy download go? Oh, we pulled embassy. Cool. Let's see if there's any submodules to get. Git submodule update init recursive. Nope. All right, pulled embassy. How big is this? Oh, 23 megabytes. That's a lot less than that CubeIDE thing, and I actually have all the ARM compilers already installed for Rust anyway. But anyway, we'll table that for after CubeIDE, right? So CubeIDE, let's maximize that view. We're gonna go, what do we got here? Start a new project, import example. What does that do? Import example. I didn't do anything. Oh, it froze? What? No, wait. What is it doing? Oh, you know what? Watch this really be bad in Wayland or something. Like, I don't even know. Wow, it's... Oh, it's downloading stuff. Look at that. Oh. Well, that's great. And we're on a really slow internet connection right now. Perfect. Maybe now we can click import example. Hey, it's doing something. Oh, that's no longer doing something. Oh, it's occasionally doing something. All right, well. Oh, hey, download selected files. Yeah, it's doing something. Can you tell that Linux is an afterthought for them? Is this based on Eclipse? Yeah. Oh, no. Oh, yeah, it is downloading stuff. Okay. Interesting. Oh, I wonder how long it's going to take to download compilers whenever we want to actually build something. That's going to be fun. Oh, brilliant. Please retry later. That's lovely. I love it. If we try to click import example now, the example selection is required. What if we do cancel? Oh, does it have to download more stuff? No, what? Why does this keep happening? Oh no. Oh, I love, oh, good Lord. Oh. Oh no. Okay, well, let's wait for more downloads. Brilliant. 24, 23, 23. So yeah, for those who just joined, we're taking a look at the STM32U083 CDK or Discovery board. Where pretty much we're just trying to get something USB working, right? Because the kind of the main feature of this Discovery board. Oh, Java heap space. Oh no, heap space. It really run it. Oh God, why? Salt running Eclipse of the README. Sure, we can exit the program and let it die. Okay. What? Out of memory. Oh, we jumped into my swap space. Can I really not run? Wow. You know, that would be terribly sad if I couldn't run OBS and Eclipse and Firefox at the same time on 16 gigs of RAM. As it ate into my swap file even. Like, that's crazy. Okay, well, anyway, let's try CubeIDE again. CubeIDE Wayland. Because we're on Wayland. And see if that helps anything. All right. Ustat cause null. And we're actually going to leave htop open here and see what happens anyway. All right, so import an example. It's downloading stuff. Maybe this will work better. This is going to be an entire stream of me not being able to install this IDE. That'd be really sad. I'd just delete the stream if that happened. I went all the way to Micro Center to pick up these lapel mics, even. Please work. That would be so nice. Connection to server. Downloading things. Doing a lot of stuff. Ooh. Oh, something's happening. Something is happening. Oh, yes. Okay, got a lot further. Sample filters. Board. Oh, nucleo. Okay, okay. Maybe we can find our board in here. Be U0. There it is. Oh, nice. Okay. So these are all samples that'll work with our board. Software package install. So we got analog digital stuff, board support package, demo. Let's do demo. Download 88 megs of stuff. All right. I'm gonna do demo. Next. Location, workspace, software package repository, setup, targets, firmware. We'll just accept defaults. Finish. Please log in and download a okay. That's unfortunate. Okay, so that said help. Updates, log into MyST. Oh. Okay, well, let me turn off my view again here. Screen capture, pipewire. All right, and cool. It's hidden. So now we can go to ST, copy that. Do the password. Remember me on this device. Log in. Clear my clipboard. All right, it looks like it let me log in, and we're eating a lot of RAM. Look at that! Look at all that RAM that we're eating. Okay, let me bring the screen feedback up here. All right, we're gonna go look at our comments. Nobody's commented. All right, so go back to this. Go back to example. Initializing target selector, board, U83, demo, next, finish. And it's downloading. Okay, cool. I like that. I like that. Okay. Let's just wait for it to download. All right, and still downloading. Do 10 seconds. All right, so what will the demo even do? Do. Checking license. I have definitely not read it, but I accept it. Probably just sold my firstborn for cookies. Okay, cool. We've got something. Perfect. DK demo, drivers, middlewares, touch sensing. Interesting. CMSys, BSP. Bus sensors, glass LCD. What does that do? Cap letter map, number map, digit frame buffer. Huh. Interesting. Anyway, application startup is a assembly file. That's fun. User main. What do we got in here? We got main, hal init, clock. Oh, I don't know this framework at all. Looks like user code begin. Demo start. Sysmem. What is that? A stack break, S break. It's part of the allocator. That's part of new lib. Okay. Get pid, kill, weak, right. Huh. All right. All right. Hal MSP. Well, let's just try to build this, you know. Demo. What is in this demo? There was an extern demo, right? Or main, sorry, main.c. There was an extern demo. Right? Extern system clock, main. Where's even our example? Startup. Touch sensing. HAL driver. Out in there. HAL UART USR. No USB. Where is our actual demo program? Init demo start. Oh, demo start. And then it does a while infinite loop because of a failure, presumably, if demo leaves. Okay, how do we go to open declaration? Oh, there we go. And that was in app main. Oh, it was under modules. Okay, that's funny. Okay. Demo state start, air quality not available. Ooh, okay. Well, anyway, let's see if we can build stuff, right? Project, build all. Project built, 0 errors, 0 warnings. Okay, cool. And how do we... Well, let's plug in our microcontroller board here and see what happens. All right, powering up. Power LED came on. Can we just run this as if... What if we debug? Demo, elf, debugger, auto start. Yeah, why not? Okay. Provides a newer firmware version of the attached as. Proceed with update. Oh, shoot. I wanted to say no. No, we're not going to do that because I don't want to risk that right now. Debug. Sure. No. Error. Firmware update. Oh, you bastard. Okay, SD-Link firmware update required. Sure, okay. Open in update mode. Upgrade. Oh, and it's blinking at me. Hopefully this doesn't break. That would be really, really sad if it broke. Unplug USB and ruin my day. Okay. Well, it seems to not have evaporated. All right, debug. Waiting for a debugger connection. Ooh, this kind of launch is fine. Debugger perspective. Download debugger console. HAL init. All right, what if I say or continue? Oh, it's doing stuff. Oh, hey, look at that. It's doing stuff. Bunch of LEDs. What if I click the button when it says touch? If I click the touch button. Run mode. Well, it's just doing nothing. Run M. Stop to mode entered. Entering. Stop to. Oh, that's cool. Okay, so the touch sensor, it goes into stop mode, which means it enters an extremely low power operating. It enters one of the lowest power operating states it has. And we see target not responding, retrying in the debugger console. And then if I touch the thing, it wakes the whole processor back up. That's cool. Wake up. How do I get out of this? But how do I get back to the top level? If maybe we just have to restart the program, right? If I Control C. Oh dear. I just want to rerun the or whatever. Debug. We'll just rerun the debugger. Reboot the program, right? Yep, and it's boot. And it's oh, it's really upset at me now. It's still flashing a lot on the debugger. Maybe something. Oh, stop. Debug. Switch to debug perspective. Sure. Download verified. Let's see if it actually works this time. Only works once. Oh yeah, we gotta do our continue. There we go, continuing. Yep, STM32 demo again. Look at that. Look at that. STM32 demo. And then let's use a little joystick. So yeah, we can use the joystick to flip between different demos. So if we say, what about ULP? Ultra low power. Standby. If I click the button again, what does it do? Target not responding. Shutting down, exiting. Oh dear. Well, it died. What happened? Okay. Neat. That was not quite what I expected to happen. Let's look at what let's see if we can see what that even does. This. Oh, it just booted back up. Standby. Oh, I wonder if it just goes to sleep for a while. Low power, sleep, standby. Oh. I think it went to sleep and then it just killed the debugger because low power. 101 microamp. What does that even mean? It's probably... Hmm. 125 nanoamp. I wonder if that's actually not really the 33.3 microamp even. All right. I wonder if that's just, what do we call that? Sample text? I wonder if it actually is entering that ultra low power mode. What happens with about these demos? Air quality demo, LP modes demo. Blink, off, blink, do things. Stop modes, mode display. Deactivate wake up timer. I guess this topic's really not that popular. And or Wednesday's just not that popular. Okay. So, anywho. All right, so we've got that running. All right, so again, that's just looking at this. So let's try Let's close that. Let's close this. Close project, close project, clean, close project. I just want to close the project. If I say restart. Oh, yeah, restart CubeIDE. Interesting. Well, nope, that didn't work. What if we close? Is there a close project? There we go. And we got, is there a home page? I want to go to new, import. I want to open a sample. Recent files. Okay, how do I get back to the home page? Nope, that didn't work. Navigate. I'll go to the top level. Perspective. Open. Okay. I don't want the Project Explorer. I want that top level view that we were in. Information Center. There we go. Okay. Import an STM example again. Let's see if we can do that USB-cdc one that we saw at the bottom. So if we go back to our board, go back to the one that we have, this Nucleo, or the Discovery. We saw that HID CDC ACM. Oh, look at that. They already have a composite interface. Well, let's just start with the serial. Let's just start with that and see what happens. It's going to download stuff. Okay, cool. What if we build that? Project, build project. Yeah, it's built on Eclipse CDT. Oh my God. That's funny. Oh, did it compile? Project, build all. Oh yeah, 0 errors, perfect. Project, run, selection cannot be launched, there are no recent launches. Oh, run, debug. Okay, start up, source main debugger. Okay. Our debugger connection, switch to debugging perspective. All right, debugger, continue. Well, I guess we have to plug in a USB interface, and I'm gonna unplug my power cable here. All right, let's try this, see what happens. We need to, let's look at dmessage to see if anything interesting comes up while we plug this in. Look at that. USB device found. STM virtual COM port. Oh man. Okay. Picocom dash B, say 1 megabaud 123 dev TTY ACM1. Terminal ready. What does it do? I see the serial port, but does it actually like say anything? Do I push a button? No, it doesn't look like it's doing anything. What is it doing? RX ThreadX and NIT. Oh, ThreadX and NIT. That must be a RTOS of some kind. Main. Well, now what? Debug, application, user, Azure RTOS, core, app, ThreadX, TX kernel enter, main, USB-X, app. Okay, interesting. Maybe CDC ACM, line length, activate, thread entry, CDC ACM. Do we ever actually write anything to it? Yeah, app threads, Azure RTOS, app Azure RTOS. TX define. I don't actually know if it does anything. Docs, readme, thread entry, used to read data, USB-X, USB write, used to send the received data over a UART. Oh. Well, I don't have a... Oh, I do have a... You know what? I wonder if it's using the debugger's UART interface, which would be 0. No. If I do 115. Oh, now it's decidedly not happy. Oh, terminal ready. Nothing's happening. Maybe what baud rate does the UART use? Is that a factor? I don't know. I don't know. Console. Is that doing anything? Nope. Oh. Okay. Read received data over the read thread. Send using the UART. Enumeration, red LED toggles. If an error occurred, nothing's toggling. Notes, stack. Oh, okay. Can use CN3, which is not through the PC through Type-C standard A, CN3. Maybe that's the... Oh, that's probably the USB-C port. I don't see a label for CN3. CN4 is a plug. CN3. Where are you? CN14 user. I don't know if that doesn't sound right. Oh, CN3 reserved. Lovely. Access connected to the ST-Link MCU by default. It will be 115.200. Maybe we got to connect both at 115.200. (115.200). 115.200. Nope, nothing. Flow control none. 8. This dynamic. For example, it can be. Oh, it's configured as following. Open your preferred toolchain, rebuild, load, run the application. Well, that's not. I mean, it's working in the sense that the interface is coming up. I just don't know actually how to get anything to come out over it. Okay. Okay. Hello, two people. All right. Yeah, we're trying to debug why we've loaded up this UART sample thing here, and we're trying for the discovery board, and we're trying to get it to work here. It says in the README that it should the virtual serial port should send data out of the UART, and I don't know if vice versa, but we're looking through this. So like app threadx doesn't really do anything, but yeah, CDC ACM is initializing virtual serial port. Then it calls a UART init, and then transmit UART handler plus user transmit buffer. Yeah, write thread entry. Interesting. Okay, well, that's funny. Terminal ready, terminal ready. Nothing's going on. Okay, well, if we did like cat, TTY, ACM1, then picocom. Nope, that's not working. What if we echoed foo into ACM1? Nope, that isn't really doing anything either. All right. Well, I don't know what to say about that one. Presumably I'm doing something wrong. Oh, well, you know what? If we have a debugger, why don't we try placing a breakpoint on UART send and see if we can see anything, right? UX device, yeah. UART, hell UART receive, UART handler. That's the mode over. Okay, so UART handler, this is the CDC ACM device, right? Where's the actual write to the UART, though? Does that happen in CDC ACM too? VCP config, RX complete callback, HAL receive stuff, ACM write thread entry, send data over the class CDC ACM write. What does the read do then? Read thread entry. ACM read. Oh, it doesn't actually use the virtual serial port on. Oh, it's not using the hardware UART. It's supposed to be echoing back to the transmitter. Send data. Well, I mean, write thread is doing write to the UART, read thread is doing read thread, but RX new received data, who sets that? HAL UART callback. Write thread, wait until that's set. Who calls this? Someone calls that. Who calls that? How does that get past anything? USB device X. Interesting. Anyway, if let's plunk a breakpoint on read anyway. What if we did hell UART transmit? Send the data via UART. Oh, if we read stuff, send it via UART. Well, what if we put a breakpoint here? How do we insert a breakpoint? Debug. Oh, that's how. Okay. Oh, SIGINT. It did a thing. Oh, program received while one. Okay, well, cannot execute this command while the selected thread is running. Did we lose the USB device? No. What happens if we try to connect to it now? Picocom ACM1. Well, it's truly, truly unhappy now. Terminate and relaunch. Let's try that. Console. Waiting for debugger connection. Switch. It's doing stuff. Debugger console. We're going to continue. And presumably we'll have lost our... Yeah, because that died. If we send... Oh, yeah, we sent it a thing and now it hit a breakpoint. Perfect. I'm going to jump over that. We're going to... Step over, actual length not equal 0. If we hit continue, is that this? Resume. Okay. Continuing. It's also very dead. Up. And continue. And okay. So it's definitely reading stuff from the USB serial port. But why aren't we seeing the transmission? Maybe, I don't know. Interesting. Okay, hold on. I need to stop that. I need to stop the breakpoint. I need to continue. Continue. There we go. Oh, it's doing stuff. Oh, shoot, it's working now. Awesome. I just didn't have it configured correctly before, I guess. Okay. Picocom. Oh, yeah, now it's working. Okay, so, yeah, and if we select this terminal, it comes out of the other one. And if we select this terminal, it comes out of the other one. Perfect. Okay, it actually is working. I don't know what was broken on my end anyway. Okay, sweet. So okay, we've got USB working. Well, okay, we're running a sample that has USB, but it's working. That's cool. I like that. And we also we showed that the debugger worked. We could put a breakpoint into CubeIDE here, and we were able to debug it. Nice. I really wish this didn't take up so much vertical space. Switch. Oh, did I hit? Oh, I hit terminate and restart, not just terminate. There we go. Terminate. Okay. Alrighty. Let's close this too. Let's try that composite device one. Close project. Help information center. Import an example. Board. U0. Lots of power examples. I mean, we're going to want to know how to use those. Okay. Is this the one that was the composite? Yeah. HID and CDC ACM. So it'll be some kind. Okay. Oh, here's the actual what it's doing. Okay. This application is designed to emit a HID mouse and a UART, USB UART bridge. Following the virtual COM port implementations, the code provided requires provides all required device descriptors, framework, and associated to both classes descriptor report. Oh, God. To build a compliant composite ACM device at the beginning, threadx call the function. Oh my God. Okay. This was not written in English. This was translated from something. Either way, at this stage, USB is initialized. CDC ACM HID driver, app UX thread entry is used to do the DRD HAL PCD driver. Start the device. Read write threads on CDC. It's doing the virtual COM port UART thing, and also HID entry sends HID reports to automatically move the PC host machine cursor. Okay, so it might just jiggle the mouse or something. I don't know what it'll do. It'd be really cool if it used the joystick to move the mouse on the screen. That it doesn't say that it does that, but that would be cool. Okay, either way. Next, finish. And we got this, and we're going to say project build all. And it's building stuff, build finished. We're going to say run, or we're going to say debug. And apply and OK. Build finish, waiting for debugger connection. Switch to the debugger perspective, debugger console. We got our temporary breakpoint at HAL. We're going to watch the console disconnect because the thing's off. Continue. Okay. We got an ACM device. We're going to try to get the other. So we do picocom 0 and we do picocom 1, we do that, so that's still working. Okay. And so what moves the mouse? So dmessage, we see a HID generic mouse on HID raw. So what if we do EV test? And we see event 18 is that, and it's not doing anything. But we can load it as a HID device. So maybe, let's go look at the, maybe it's listening for keys in order to do something. Core, USBX, app, UX mouse, cursor step, mouse activated, HID, do a thing, thread sleep, get pointer data is HID event, increment counter. It feels like that's not running because we're not seeing anything happen. What is cursor step? 10. Okay. But it's not submitting any mouse events. That doesn't make it do anything either. Okay. Do we have to do something funny? Thread entry. If UX device configured, thread sleep, else thread sleep. Get pointer data, static. Well, let's plunk a breakpoint right here. Oh, yeah, and it stopped there. Oh, it did not stop there. It's still running. Okay, okay. Let's grab our terminals here. Picocom ACM1. Oops. Picocom ACM0. Okay, so that's still running, which means this get pointer data is not being called. Or it might not be. Okay, because I put it on the static thing. That might be why. Okay, continue, cannot, while still running. Okay, okay. Counter less than 0 if counter get pointer data. Oh, wait. Check if the user button is pressed. Oh. It didn't say that. Okay, so we've got our Picocom stuff. Terminal can send either way. We've got our mouse input, and I have to push the user button. Which one is the user button? Well, that's the reset button. Joystick. Oh, hey, I just clicked the joystick. Okay. Do that. And then we'll just say continue. Okay, hopefully it's not dead. Well, it really locked up full screen. Okay. Well, there we go. If I push the user button, stuff happens. Okay, that's funny. It's doing stuff. So every time I click the joystick, it moves. It's not sending it's not actually using the joystick to control the mouse. But that's neat. All right, so we proved that works. And so if we say stop here, I should be able to get my mouse back, right? Why is this stuck in full screen? I don't like this. Hold on, F11. No. Why is this stuck? There we go. This kind of switch. Okay. There we go. All right. Something just funky. Okie doke. Download, verify, debugger console, continue. Yeah, that's working. Nice. Sweet. Actually, I can't click this anymore. What? Oh no. Oh no. Alright, this is just, it's taking over my, there we go. The mouse is taking over primary control because it keeps doing stuff. Okay, I unplugged the USB cable. Okay, so, oh wow, okay, nice. Let's see here. All right, it'd be really cool if we could modify this. Okay, before I say I'm doing too much, let's see here. 8, all right, let's see. Let's see, how hard would it be to merge in the joystick logic? Like, to make the... How horribly can we hack this? So if get pointer data, right? UX device mouse get pointer data, right? Okay. So we got to give X, we got to give Y, counter plus plus, set the X position, set the Y position. And, oh, user button state. If the user button is pressed, send the event. Otherwise, just keep sleeping. Okay. So how was it actually clicking the mouse? I don't know if it was actually submitting mouse, per se. Cursor step. Negative cursor step. Okay, well... Let's see. Let's look at one of these other, or let's look at this HAL MSP thing, right? Joystick, right? What did the joystick thing look like? That'd be BSP, right? How do we, drivers, HAL driver, middlewares, ThreadX, USBX, CSP, stuff, all this stuff. Debug, dock, startup. How do we get the joystick? I want the joystick. Where user, user. Hell. Okay, well, we're gonna have to close this project and then reopen the the demo and look at how it did the joystick. So we're gonna say close project. We're gonna go back to the demo here. We're gonna go to, okay, drivers had this BSP component thing. Discovery C. And it had a, what kind of joystick stuff was in here? Joy and knit. BSP, joy and knit. Joy type def, joy D and knit, joy get state. Key pressed converted type def joy int 32. If none, if cell, if it's around 0, if voltage down, left, right, up. Okay, so can we, drivers is the BSP, the BSP is not in here. That's interesting. How did we get the user button? Where did that come from? User, USB-X, app, mouse. Where did UX device mouse? IO user button state. Where does that come from though? Where's HID mouse, user button state? Who sets that? That's coming from somewhere. Declarations, project. User button state. Theoretically, that's coming from somewhere. Any comments? No. Okay. If anybody has any questions, please feel free. I'm thumbing over to look at them when I can. All right. User button state. But who is setting this? That's the question. It's defined as an IO thing. Where does that come from? I doubt it's in here. User. Yeah, no. User button state. Interesting. Well, let's see if I can add the BSP to this device. Do I configure? No. How do I project? How do I add stuff to it? Navigate, search, help, run project, generate code, file, edit. How does this work? Project, build targets, working set. Properties. Cancel. Okay, hold on. Let me close the demo here. If we go under drivers, we can add drivers. I don't know. Close project. Remove include path. HAL driver. What is IOC? Configuration tool, tool perspective, yes. Loading the IOC. Rendering UI, oh boy. Oh, okay. Project manager. Tools. Oh, oh no. What have I done? Oh. Let's close that. Yes. All right. Well, oh, maybe user button is in here. Because it was externed, right? User. No. All right. User. Yeah, no. It's not in the linker script. There's a way to search this folder for user something. That's embassy. All right, so we're gonna go to STM32Cube. Oh no, CubeIDE workspace, UX device, ACM. We're gonna look for user something. All right, and it's in app USBX device. Okay. Interesting. Oh, user button state. Oh. If GPIO pin is button user pin, then XOR state. Okay. Interesting. Okay. That's fine, I guess. Oh, but it is pulling in the HAL, right? Or no, the HAL, not the BSP. Can we pull in the BSP? How do we add? Theoretically, we can add stuff, right? HAL GPIO AXTI rising callback. It's probably these like predefined files, right? Go to open declaration. Okay. Yeah, how do we, one of the whole things about Cube is there's supposed to be like a way to add stuff to these projects, right? That auto-generate some things for you, if I understand. Help. Integration tool, manage embedded software packages. Maybe this is it. Maybe it's something through here. U0. Oh, that's not it. Well, crud. Okay. Show view. It's all perspective, navigation, preferences. That's window preferences. Project Explorer. How do we... We're gonna have to go to Google or something, aren't we? Okay. STM32CubeIDE. CubeIDE. Add BSP to project. Thread X. Okay. Prerequisites, do the thing. Okay, board selector, do the thing. Add BSP. Uh-oh. Oh, wait, they're just doing it. Open projects from file system. Drivers. Oh, do I really have to copy a folder into something? Oh, that's great. Okay. Sure. It's a manually forget automatically doing things. Repository, that, drivers, BSP. Okay, Cube, IDE, workspace, ACM, drivers, do that. Okay, perfect. I guess, right? Okay. It was also the Nucleo. Hold on. Let's look at how it added it in the demo. Drivers, BSP, component. Oh, yeah, look at that. All right. Components, common, sense. Oh, No fun. Copy paste the folder in your project directory. Nice. Then refresh. And then go into core include helconf stuff. Begin. When was this published? Edited on 2025. Okay, okay. Fine. Refresh. Add that datasheet. Okay, well, let's try that. Let's see what happens. Okay, so we're gonna refresh this. Refresh. Come on, show me the thing. Show me the thing. Refresh. Okay. That didn't work. Okay, fine. I missed something. I wasn't paying enough attention. Okay. So we added the folder. We copied the thing, copied the BSP, pasted, oh wait, hold on. Fine. Add BSP, drivers, copy the BSP. Now copy this directory, paste it in the drivers of your project, delete the rest of the folder and only keep the ones related to your kit. Okay, fair. So we'll delete Nucleo because we don't have that. Move to trash. All right, fine. Now go to and only keep the following component. Common. Whatever. Utility. Add BSP. Right click and say refresh. This will add the BSP folder and all of its sub things to your project. Refresh. I don't see them here. What the heck? Come on. Come on, doc. How about we close it and reopen it? Close project. Reopen project. Should be there now, right? Nope. All right, did we paste this into the wrong folder? That would be my luck. Oh, yeah, look at that. We deleted that out of the demo. Hit ACM. No, we did this. We delete that. Move to trash. Hit ACM. Refresh. We have to say import. Nope. Existing. Import resources from the file system. Browse. CubeIDE, workspace, ACM, drivers, BSP. Finish. Drivers, BSP. Oh no. New folder, BSP. Components. Okay, cool. Now what happens when we build this? It probably just blew up in my face, right? That's how this will work, right? Yep, blew up in my face. Okay, cool. Nice. Discovery conf. Template. Nice. Duplicate. conf. Nice. Okay, unresolved include. So we're gonna have to convert conf to source format, move, rename to not template. And then we're going to define. We'll just let all of this be defined. Why not? We're hacking this together. Build all. Oh, that didn't work. SPI, unknown type, all of this stuff. Open declaration. Oh no. Well, I mean, it was worth a try. Joy init. All right, is MX-ADC. Oh, it's analog? Okay. Yeah, I wonder why a CMSys not here, low-level discovery.h. Joystick. Unknown ADC type handle. Uh-oh. HAL Cortex XTI. Okay, I wonder if there's a bunch of stuff that didn't get brought over, like the ADC driver and such. Drivers, workspace, demo, source, no, demo, drivers, BSP, here, or no. HAL driver source. Ah, that's what it is. There's a bunch of stuff that didn't get brought over. Okay. So what's not linking? ADC's not linking. That's broken. ADC's busted. Glass is not running. LCD handle. Request remember instance and something that's not a structure. A union. Something's broken. MCU, LCD con 0. LCD RAM register. Undeclare. Oh no. Okay. Well, that's going to be a bit more difficult than we expected. So how does LCD RAM register 0 get defined in normally? If defined, use disco revision B. All right. LCD RAM register. HAL LCD. Oh, well, I mean, it's the file is in here. It's just not imported, right? Oh, we gotta import stuff. Okay. Add or import file system from directory. Drivers, HAL driver, source, inc. Open. We're going to do ADC. We're going to just do all, right? Why not? Select all. Okay. Finish. Okay. Cool. Now we're going to build project. Project, build all. Building workspace. Let's see what happens now. Up, still got errors. Something in here broke too. Oh, because these are all templates. Okay, well, let's just delete the templates, I guess. I don't want to delete from the file system, but whatever. All right, build all. I don't want, the templates are going to fail probably. Or not. The templates worked. LCD RAM register 0 still failed. HAL LCD.C. If def module enabled, but it's not because we copied a template. HAL conf HAL. Here we go. Open declaration. And where's HAL conf is the thing, right? Conf. Discovery conf, HAL conf. This HAL conf template. Define. Is LCD not defined here? Oh, LCD is LCD if def module LCD. Define. Yeah, all right. But where does it actually put the conf temp? Oh, there it is. Core Inc. HAL conf. I see. There we go. Vim that. There we go. Okay. It's probably a way to access it up in here. Yeah, core. Does it even? Middlewares, ThreadX, components, common, BSP, app, user, core. Yeah, they don't even bring in the headers, or maybe the headers are hidden. Anyway, we can just edit it here. So we're going to bring in the ADC module. I'm going to bring in the LCD module. Uh-oh. Bring in the LCD module. Might as well bring in I2C just in case. All right. Now let's see what happens. Project, build all. Some stuff still failed to compile. The LCD succeeded though. M sensor is not present. I don't know where that is. Discovery bus still failed in here because something's not. Oh, SPI. We need SPI. Somebody who actually knows how to use CubeIDE is probably screaming at me for just maliciously abusing this program. Oh well. Oh well. Oh well. Thank you all for all those who are watching. Thank you for watching. If you have any questions, please post them in the comments. I am trying to check them. All right. So we enabled that. Project, build all. We'll have to find where that environment sensor thing is at some point. Okay, yeah, that succeeded now. Now it's just the M sensor. Where is msensor.h? Find.msensor.h. We got components common M sensor in the drivers. Oh, interesting. So in STM32CubeIDE, drivers BSP. I wonder. You know, I wonder what happened here. Anyway, we probably just broke something horrifically. But find. Anyway, env sensor is in components, common env sensor. So will components common env sensor.h. All right, env sensor.h. I see it there, but it is not where it's supposed to be, I guess. Maybe we just delete environment sensors from... No. Let's try to figure out how to fix this. You know, I wonder if what we did with this import thing actually just created this new CubeIDE thing that's happening. Oh, I don't even know. Oh well, whatever. But environment sensor is supposed to be there. I mean, it's in this folder. I mean, it's both in components. Let me check if what if we just YOLO swaggins to this. / components common env sensor. Just really just YOLO'd this here. Okay, nice. Oh, no environmental sensor has been selected. Instances number. Use env sensor number. Well, use. Well, let's see where that's defined in the other project, right? Demo. That would be done in envsensor.h. Okay, in here, env sensors. If use, well, define it as 1. If not defined, define it as 1. If it's equal to 1, do that. So that means defined as 1. If env sensor's number is 0, which means somebody is defining it to 0. Demo inc discovery.conf. Must be being set to 0. Use env sensor. Okay, 1. Yes. Project build all. That built. This is still throwing an error. That's also failing because components STTS32H, because somehow I've got the include path. I've really done something horrific with the include paths. So we're just gonna do this for now. This is horrible, but we're just trying to get this to work in some capacity. Wait, it's getting close. MSP template. Well, we don't want MSP. Delete. We don't want the template. Okay. Yeah. Project. Build all. I wonder what MSP is. Not the Texas Instruments thing. It built. We built it. Yes. Okay. Components. No, we're doing horrible things to this. Let's close all of this stuff so we don't reduce the amount of logical noise. Okay. Let's see how this other project does BSP init, right? RG, BSP init. Do we have to do a BSP init? No. BSP. Joy. No. RG. Ripgrep. BSP. Joy. Init. No. How does that even work? Joy. BSP. BSP. Okay, hold on. Discovery.h. How does the joystick work? BSP joy. If use the BSP joy feature, which we would like to use, discovery conf. So use joy feature. Yay, we did the thing. Yes, we're using the joy feature. If defined, what is the black text mean? Anyway, discovery bus, discovery h, BSP use com feature, conf. Well, no, stop. Com init, right, com init's gone. Where's joy? Joy get state. There should be a use joy feature. Use BSP joy feature. Should be defined as 1, which it is. Wait, if... So why is this... If greater than 0, then don't use that? Wait, I'm confused. All right, hold on. Or RG use joy. What? What? Hold on. Use BSP joy. Template discovery use greater than 0. Define it as 1. Yeah. Okay. Discovery conf. Use joy feature drivers. Use define 1. Use joy feature greater than 0. Okay. I mean, that's fine. What do we call BSP underscore joy underscore net? RG BSP underscore joy / demo. Oh, there we go. There we go. We would call it default MSP. Uh-oh, it does use MSP, whatever that means. What does MSP mean in this sense? All right, so register MSP callbacks. I'm gonna find / demo grep MSP. Hal MSP. Well, we should probably copy / demo STM32IDE. Drivers, BSP, DK, no, HAL drive, sorry. HAL driver, source, HAL MSP, no. Okay, yeah, demo, source, sim, HAL, ls demo source STM star. Okay, copy. We'll just copy that to drivers. HAL driver source. Why not? We'll just import that. This is not the way we're supposed to do this. This is just me really just getting irritated at this. Okay. Import file system Create links. Oh, God. MSP, whatever that actually means. Okay. I really wish I could just refresh. Why wasn't the refresh working? I don't get it. Anyway, what even is MSP? Oh, it's probably related to the clocks. I don't know. I don't know. We're just trying to use the joystick to control our virtual mouse. Oh. Of course it breaks. Okay, we need comp and timer, or comp. We need comp system. So we need to go back to our HAL config. Comp system. Project build all. Still broken. MSP fails. What now? Oh, RTC needs to be... Okay, we need the RTC system. Project build all. I'm also going to need the TSC system and, yeah, the TSC system. Project build all. Still didn't work. Now what? Multiple definition. Application user core. HAL MSP 0. Oh. Oh. Okay. User core MSP. MSP. Yeah. Look at that. All right. Well, nifty. RTC, TSC. MSP. Well, okay. All right then. Well, let's just delete this thing then. Delete. Okay. Let's see what happens if. Well, I mean, we need to go back to our app device because we need this user button thing anyway. User button state. Callback. If GPIO pin is button user pin, but I don't even know where this is declared anyway. Open declaration. GPIO pin 2. This is in main.h. So I don't even. Button pin. User button state. Well, all right. We just need a place where we can call the HAL init, your init app, PCD app device init. Controller HAL driver. Allocate hid mouse param. Well, mouse, hid mouse. Hid mouse activate, get pointer data, user parameters. Well, I mean, come on. How did this actually read the joystick again? BSP Joy in the demo. all it called was init dinit get state, right? That's all it did. Init dinit get state. So it called init in the discovery code in discovery, BSP joy init. Well, we'll just plunk that's all it ever called. Oh, interesting. Oh, that's just the definition, sorry. Who actually calls init? Oh, it's in app main. Okay. Vim that. Vim BSP joy init. Okay, joy config. Who calls joy config? Joy initialized. Okay, initialize the joystick pins. So we need to call this somewhere. Joy config. BSP. Joy initialize, not even system hardware init. Who calls system hardware init? Nobody. System hardware init .. demo. Demo source main. Okay. System hardware init. It's called after touch peripherals system clock HAL init later on. Okay. So what if we go to main? We see HAL, RCC, hard stuff. And we see all of its things. HAL init, DMA init, user code init. Okay, okay. It's during the user code begin to section that it does that. So, all right, then we'll just look at our joy init BSP joy init. Okay, just call that. We'll just paste this here. Build that. Project build all. See what happens. That's not happy. Undeclared. Joy all. Undeclared. Undeclared. Open declaration. Oh, okay. So that just didn't work at all. Maybe this was including a bunch of BSP stuff. App main.h, right? App main.h. Main.h. User code. Okay, how do I get to main.h? Name main.h. Core inc main.h. Okay, okay. User code includes. We're going to include STM32U083 U083C discovery.h. Project build all. And that sort of worked. Something clearly didn't. Something clearly is not correct. Replace editor content. Okay. Clearly something is wrong. I need to be able to view appearance. How do I see the errors? I need errors because it's not building. Something is incorrect. Project build all. No, give me that back. Build targets. I need the compilation log. Show view. Problems. Where though? Where though? Okay. Where though? Okay. Okay. Something is wrong. We need to be able to view our compilation errors. Come on. Come on. How do I reopen? I minimized it and I don't know how to get it back. What if we do just clean? Clean. Project build. And it's definitely very unhappy. That's probably not good. Device configuration tool. Uh-oh. We broke something. Broke something. Broke something. Oh, no. How even... I really don't like this IDE. Let's just exit. Try to reboot it. Reload it. There we go. All right. Nope, nope, nope. Hold on. Nope, that's the wrong window. Nope. Kill all the PicoCom instance. Here we go. Wayland. 38. Hey. There we go. That looks like sort of the window we had before. What if we do a build? Project, build all. There we go. There we go. Now we have errors. Nice. I like that. There we go. It failed to include that header because it can't find it because we probably really goofed up the include paths because I'm definitely not using the file import stuff correctly. I really need to figure out how I'm supposed to add like the BSP modules to a project correctly, because that article that I followed just doesn't really seem to be doing the right thing. But anyway, so if we look for where main.h is, and we look for where STM32U083C discovery.h is, it's going to be in ... this path. Oh, that's disgusting. Okay. Anywho, ... that. Oh, that discovery. Oh, God. Nope. Wait, I want to go back to the one that I was viewing. Is that the one we've been editing? Conf. Joy feature. Yes, that's the one we've been... I don't actually think it matters, but whatever. Project, build all. Haha! It built. Okay, and we were able to compile all of the joystick stuff. All right, so in theory, if we put a breakpoint there, and we run the code, run debug, Okay, debugger console, continue. There we go, BSP joy init. And we're gonna just step over. All right, perfect, that worked. Okay, I like it. Okay, that seemed to have worked. That's good. Okay. So initialize the joystick. Seems to have worked. So how do we use the joystick? So vim joy. Joystick status, get state. What is the joystick status? What does that actually look like? Joy 1, BSP, get status. So we're gonna go to the it's that app USB mouse thing, right? No. Yes. Where are we? Why am I here? Okay. App, user, core, no, wait, USB-X, app, mouse. Okay. And we're gonna need to include some stuff. Probably gonna do the same thing as that main thing. We'll get there when we get there. So set report, get pointer data. All right, and so we're gonna change all of this. Oh, they use this stupid thing. Okay, well, anyway, we're gonna say BSP get joy state 1. We're gonna compile that and see where it breaks. Probably need to include some headers here. That worked somehow. Oh, it's because it's in main.h. Okay. Open declaration. Okay, what's the type of, no, we know. Let's just use what we're supposed to do. Drivers, BSP, that. It's gonna be called joy pin type def. That's what get state, no, get state. Hold up. Okay, joy init type def joy pins. Okay, get state returns. All right, hold up. Get state returns init 32. Key pressed returns key pressed. Returns key pressed. Okay, up, right, cell, which might be just select. Down, left. Okay, up, down, left, right. Okay, cool. Why not? So we're going to go to our mouse thing here. We're going to delete that stuff. Well, not going to delete X and Y counter, whatever. If, we'll do else if counter is step. So we're going to say that means left. We're going to say if int 32 state equals that, that's going to go below the statics. Fine. Say if state equals joy left, else if state equals joy down, else if state equals joy right, else if Well, we'll copy this. If state equals joy up, else, and then this is an else. Okay, cool. Counter plus plus. We're just gonna ignore counter. Project build all. Perfect. It built. Okay. So we're going to go to that joy init function and remove the breakpoint. There we go. Remove that breakpoint. And we're gonna do. Oh right, we're gonna have to change the user button thing, user button state, user button state. Just comment that out. Okay. Project, build all. Okay. Run, or debug anyway. Okay, waiting for debugger connection. Let's see if this joystick can now control the mouse. Well, we gotta plug it in first, but we're gonna run that. We're gonna plug in the USB. Hear the bloopy bloop. It works. Up and down is not doing what it, or it looks like the y-axis has been programmed to click versus but up and down is moving left and right. Okay. Actually, we can look at the EV test. Well, it's doing something that we want, or it's doing something. Not quite what we want, but a lot closer than farther, right? Okay, 18. So if we do left, right, button middle. Oh yeah, so button right, button middle is that axis. And then if we scroll up and down, we get the relative. Type 2, type 4. Well, all right, so it's not quite sending the right commands, but it is sending HID information, so that's really nice. So, okay, 9:50. I'll give it a couple more minutes. All right, so let's stop the program here. And let's figure out what the hell's happening with our HID mouse, right? Because HID event set, HID event. Mouse event length is fixed to 3. HID event buffer, F2 for focus. Well, that didn't help. I wonder if 1 is, okay, that's funny. Well, anyway, we do know that something is working. So that's funny though that Y is, so left and right, assuming that's what I was even pressing. So let's see, let's run this in debug mode again, see if left and right is even what or up and down was doing left and right. So continue. Okay, so up and down is triggering the left, or well, up and down is moving the mouse left and right. But I don't know. Well, so up, so Y, so the Y value here is moving the X-axis. And the button state okay, you know, oh, sorry, we gotta continue. So the button, yeah, so X being cursor step is clicking the button. So whatever Y is doing that. So the X-axis, so if we did that, if we flipped these, what if it was button state X and Y? What if that's what's happening here? So project build all. And we'll run debug. Switch this perspective switch. Okay, so... Oh, right, we gotta continue. Okay, so down, up... Okay, so that's working. Up, down. Oh, I did it again. X... So left triggered, oh, it's the breakpoint, sorry. Okay, so I got left and right flipped, but up and down works. Left and right is inverted on accident. Perfect, okay. Okay, we're just going to flip left and right, so left needs to be negative X, right needs to be positive X. That makes sense, honestly. And if, and we'll say static int, and then B is 0 for this. And then we'll say else if, sorry, the else if state equals joy cell, and we'll say B, we'll say B equals 0, sorry. Well, I'll say B equals 0, B equals 1. And then we'll assign this to B. And B equals 0. Okay. We'll say y is equal to 0, x is equal to 0. Okay, cool. Else if, we'll build this, and that should let us click the button if we hit the joystick correctly. So we do that. We're going to run it. Waiting for debugger session. Oh, I wanted to debug, not just run. All right, switch, perspective, continue, and now we should be able to do left, left, right, down, up. If we click it, it clicks the mouse. Perfect. So yeah, there we go. We have extended this demo in the most horrible way, broken way, inappropriate way possible to merge the frickin' BSP code from that other demo into this demo, and then use the joystick to feed a USB HID peripheral. And also, if I open up PicoCom, the frickin' serial port should still work. So that's 0. And then this is 1. It comes out there. We go to the other one. It comes out there, right? And actually, we can use our little mouse to select which window we're typing in. So we do that, and then I use our mouse to click on the other window. I type over here, and it prints out over there. All right, you know, unified little demo here. Okay, that's a lot more forward than I actually. It's a lot closer to anything I thought we were going to get tonight. Okay, so let's kill Picocom here. Let's kill the microcontroller. I'm going to close Cube, and let's check out. Let's spend the rest of the next couple of minutes just checking out Embassy and seeing if that's anything interesting. And then, all right, so we'll close that. We'll close that. We're in Embassy on this side, so we'll close the Cube link. We're gonna have to figure out a much better way of using Cube on importing that BSP stuff, because that was definitely not the right way of doing it. But anyway, so we're gonna go to Embassy. We're gonna go to the STM32U0 directory, cargo build release, and see what happens. This might take a bit because we got to download the latest version of stuff, apparently. We'll see how far we get. Why I don't understand why that refresh wasn't working, because that's clearly something that was going wrong. Anyway, we'll have to look into that more in the future. And that's downloading stuff. We'll just close this directory here. Again, if anybody has any comments, questions, please feel free to ask. I'm clearly trying to check the comments here, you know. Hopefully the audio is not too bad as well. We're using the lapel mic that I got just recently, these DJI minis. All right, downloading. That's fine. Really ought to get me a Stream Companion app for my phone or something, so I can respond to these things off camera, or not have to tab my. I have it up on a second monitor that's not being cast on my desktop, but because I'm on my laptop tonight, it's a bit different. Okay, keep downloading stuff, cargo. It's basically pulling all of the compilers it needs for potentially anything in this repository. Yeah, Thumb V6 is Cortex M0 Plus, which is actually what's in this chip. You know, V7 is, you know, Cortex M3, M4 series. Actually, I don't know E or M. Some of these V7EM, V7M, the Cortex M3, M4, those are V7EM parts. V8 is like Cortex M33, like the Pi Pico. You can run Embassy and WASM. Interesting. Oh, I guess, yeah, look at that. Doop. Rust standard. I just wanna build this one. Come on. Do the thing. Go fast. It's just hotel Wi-Fi limiting me to 10 megabit. Right? 10 megabit. Yep, 10 megabit. 1 megabyte. 1.3, 1.1. Yeah, it's 10 megabit. See what happens. Downloading component. Downloading component. Rust C. How are y'all doing? Yeah, and so we're basically, for those who don't know what I'm doing right now because you weren't here earlier, we're basically, so we did a bunch of cube stuff, but now we're just, for the last couple of minutes, we're just going to check out Embassy, which is a Rust-based, it's not an RTOS. Technically, I don't even know what you would call it. It's rather than being a threading system, it uses the Rust async await, basically coroutines, in order to write all of the tasks. And it does. There's basically an event loop internally, and anytime you await, it's kind of like cooperative scheduling. There is no preemption. You would have to call await in order to yield execution. So while this task is waiting for this, 150 millisecond timer to expire, it can be doing anything else. So don't write any complete 100% busy loops, otherwise you'll hog the CPU. And we're just trying to compile like an STM32 demo for this. I wish it'd give me progress bars on some of this, but downloading Rust format, cargo. Okay, installing components. There we go. That should be a lot faster than the downloads. And we need VA VR because some of the STM32s have application processors in them now, like the STM32MP series. There we go. All right, building, hooray. And so we're building these demos. Not entirely certain what all will be in here. Metapack, Embassy STM32. USB serial bin. All right. So if we look at what's in build.rs, magic D format. Okay. So if we look at source bin, USB serial.rs. So what if we did cargo run release? Actually run debug. Is that a thing? Okay. Cargo run bin USB serial. Oh, we got to compile the debug version. Actually, let's do the release, right? Probars. Oh, it's flashing. Trace, accepting, setup, waiting. Whoa, it's doing stuff. What happens if we demessage? What happens if we picocom ACM1? Setup waiting. Oh my god, it's echoing. We can see what's being echoed. So 1, 2, 3, 4, 5. Whoa, that just worked. You know how much easier that was than Cube? We just git cloned and then cargo build and then deploy and it worked. Oh my god. That's so much easier. I mean, obviously configuring the device is probably not straightforward, but wow, okay. That's going to be fun to play with in the future. Okay, I like that. That was fun. Source bin. What does Blinky do? Blinky does onboard LED, right? High info LED PAP5. Does that do anything for us? I'll go run Blinky. Maybe. Who knows if this LED is connected to that pin? Oh hey, the blue one's blinking. Look at that. The blue one blinks. Nice. I also really like this logger interface. It's coming through the maybe it's coming through a UART, but it might be coming through a debugger for all I know. And Yeah, this Blinky took 18K. What did the USB one take? 38K? That's not big. It goes into suspend when you're not using it, and it resumes. What happens if we disconnect again? Does it go back into suspend eventually? As we unplug the USB. Suspend! Oh my god. Wait. Oh, wait up, reading. Maybe it goes to suspends when it's not being used, and then if we open it, it comes out of suspend and it works. Oh, that's so cool. Okay, okay. I really like that. That's fun. That's fun. And the code for that was so minimal too. Bin, USB serial. Yeah, all it did was, I mean, okay, honestly, setting up these clocks is just complete magic to me. But right now anyway. 56 megahertz operating clock. 16 megahertz HSI PLL. Okay. USB needs iClock. Okay. USB config. Give it some memory. Builder, descriptor, future, wait connection, echo. Wow. Okay. That's cool. And all it does, yeah, is let n is class read packet, pulls the data, infos it, writes it back. Nice. Okay. I mean, although some people will say that the Rust syntax is horrific, which I have to give some people some leeway on that. I know what it loosely knows what it means. You know, these are your lifetime attributes. These are your, I mean, your template args, but lifetime attribute, and then T is an instance that also lives the same as D there. Yeah, okay. Okay, I like that. Honestly, that's really all I have time for tonight, but thank you all so much for watching, and I hope you all enjoyed this look at the STM32U0 discovery. I definitely glad we figured some of this out, and we got that mouse thing working too. That was cool. Or I thought it was cool. I thought it was cool just to have some kind of sample working, right? And yeah, so hopefully we'll be able to do a stream on Tuesday. We'll be continuing with the Ross robot. We'll be cleaning up. I really am going to try to get those 3D models made so that we can start playing around with URDFs for the robot next week. But also, first thing we will do next week's stream is fix some of the bugs that we made in the FreeRTOS implementation of, or the FreeRTOS configuration, or sorry, the micro ROS configuration in order to make it run correctly on top of FreeRTOS, because we forgot, or we didn't forget, I just didn't know to enable that you had to enable a multi-thread support flag, you had to enable a synchronization primitive flag so that SMP works. But we'll have to add that. Just the mere fact that it worked at all last week is kind of a miracle. But anyway, we'll make those fixes, and then we'll maybe clean up the micro ROS code a little bit. Then we'll start working on the URDF so that we can see it in simulation and also see it in RViz, and also say how the sensors and the cameras the sensors and the motors and everything are all related to each other in the robot. But yeah, so hopefully tune in next week, and we'll see. We can look at more robot stuff, and it'll be fun. And again, thanks for watching this STM video. We'll probably do some stuff with the STM32 in the future. Probably not the near future, but we'll look at it again at some point. Probably looking at this embassy thing, because it's always fun to be able to write stuff in Rust. And specifically, looking at this board in particular will be about how do we actually use the low power states correctly. But yeah. So thanks for watching, and have a good night.